Hello students, today I am going to talking about the Rie-Mann condition, and we are starting to the statement and this proof. Let f be a bounded on closed interval ab. Then prove that f is Rie-Mann integrable on closed interval ab. If and only if for epsilon greater than 0 there exists a partition P of closed interval ab such that upper sum of f over p minus lower sum of f over partition p is less than epsilon. For proof of this condition, first of all we need to go through the first half. In this, suppose f is a Rie-Mann integrable on AB. Suppose f is Rie-Mann integrable on closed interval AB. Then let epsilon greater than 0 be given. Okay. Now, not that. Here we have to apply the upper limit by the definition of upper limit. That is, upper limit of f is equal to, you know that the greatest lower bound of partition P over the upper sum of f over P. By the definition of greatest lower bound, then we know that there exists a partition P1 of closed interval AB such that upper sum of f over P1 is less than the upper sum of f over P1 is less than upper limit of f plus epsilon by 2. Say this equation is equation 1. Then similarly we know that lower limit of f is equal to least upper bound of a lower sum of function over the partition P. By the definition we know that by the definition of the least upper bound there exists a partition. Suppose there exists a partition P2 of AB such that lower limit minus epsilon by 2 is less than lower sum of f over P2. Now if we multiply this equation by minus sign, then we get change inequalities like this: minus of L, that is the lower sum of f over P2, is less than minus of lower limit of f plus epsilon by 2. Say this equation 2. Now we have P1 and P2, both partitions. Now we have to take the common requirement of P1 and P2. For that let P star be the common refinement of P1 and P2. Then we write the P star is equal to P1 union P2, be the common refinement of P1 and P2. Now we know that by the definition of partition, that is upper sum of F over the common refinement P star is less than or equal to the upper sum of F over partition P1. And also we know that the lower sum of F over the partition P2 is less than or equal to the lower sum of F over the common refinement P star. Now if we multiply this equality by the minus sign, then we get, you know, that P star is less than or equal to the lower sum of F over P2. Now above both equalities, this one and this one, if we adding both equalities, then we get upper sum of F over P star minus lower sum of F over P star is less than or equal to the upper sum of F over P1 minus, here we have to must multiply by minus, for P2. Now we know that this both are nothing but equation 1 and equation 2. If we put this both inside this, these values are upper sum means upper limit of F plus epsilon by 2 minus this minus this will be nothing but, we will put this like this manner, lower limit of F plus epsilon by 2. Here epsilon by 2, this becomes nothing but epsilon. Now let's say it will become nothing but upper limit of F minus lower limit of F plus epsilon. Now in the statement here given is, since we know that the function F is Riemann integrable on closed interval AB, that is both the points A and B are continued. That's why we know that by the definition of Riemann integrable, that the upper limit of F is must be equal to the lower limit of F. If we apply this formula in this one, this becomes 0, and what we get is our final result. Hence the upper sum of F over P minus the lower sum of F over P is equal to epsilon. This is our final result, and here we have completed our first half. Now for second half, Suppose for every epsilon greater than 0 there exists a partition. Suppose for every epsilon greater than 0 there exists a partition P of closed interval AB such that we have upper sum of F over partition P minus lower sum of F over partition P is less than epsilon. Now note that we know that the upper limit of F is equal to what? Greatest lower bound of upper sum of F over P, and lower limit of F is equal to least upper bound of lower sum of F over P. Also we know that upper limit of F is equal to the upper sum of F over P, and lower limit of F is greater than or equal to the lower sum of F over P for any partition P of AB. Now we know that for any partition P of AB we multiply this equality by minus, then we get lower limit of F over F is less than or equal to the lower sum of F over P. Now adding this both equalities, we get nothing but final third result of A, B, and minus lower limit is less than or equal to the upper sum of F over P minus the lower sum of F over P for all partition P of AB. This equation can be deducted as question number 3. Let now for any epsilon greater than 0, as per the assumption there exists a partition P of AB, P of closed interval AB, such that we have upper sum of F over P minus lower sum of F over P is less than epsilon. That is, by the equation 3, if we have equation 3 looked at equalities, then we know that this must be greater than 0, greater or equal to 0, that is upper limit of F minus lower limit of F less than epsilon. Okay, now thus the non-negative number, it is a non-negative number, thus number is this one, is non-negative number. cannot be negative. Smaller than. Arbitrary, any arbitrary. Positive number. Epsilon. Okay, hence we can write this as that is both are equals. That is, we get our another final result of second half. Thus, f is Rie-Mann integrable on AB by the definition of Rie-Mann integrable. Thank you.